This is a short video to understand if a big engine should sound louder or quieter than a small one when road legal. So let's compare a Smart 2.4 weighing 1310 kilos with a 799 cubic centimeters engine, reaching maximum power at 5,800 RPM, drag coefficient of 0.35 to a Ferrari 488 1470 kg, 3,903 cubic centimeters, 8,000 RPM, 0.32. First, we must consider an engine with no silencer and ask what determines the level of noise it can create. It is the maximum rate at which it can use fuel. The larger the engine, the more fuel it can use for every rotation, and the faster it can rotate, the more it can use per second. So the Ferrari's engine is almost 5 times greater than the Smart and can rotate 40% faster, meaning that it can burn fuel at 7 times the rate of the Smart car, and if neither had a silencer, it would be 7 times louder. However, to be road legal, both cars need some silencing. So how is this tested? Well, it's done by a car entering a test zone at a set speed. In the first half of the test zone, the driver applies maximum acceleration and in the second half, completely steps off the accelerator. This captures the maximum sound the car can make accelerating and any pops PR bangs as it decelerates. Both cars need silencing to meet the same maximum permitted noise levels, and thus we can already see that the Ferrari will need 7 times as much silencing as the Smart to bring it down to the same legal limit. When legal, neither car will be louder than the other. So what happens when a car is idling? It uses very little fuel. It only requires enough fuel to overcome the mechanical resistance of bearings, etc. This resistance will be practically the same in both engines, and with very little fuel, there will be very little sound after going through the silencer. However, the Ferrari is using the same amount of fuel and making the same amount of noise, but goes through 7 times as much silencing, and thus when both cars are idling, the Ferrari will be much quieter. This principle is the same when a car is at a constant speed. It only needs enough fuel to overcome wind resistance, and you can see that the Ferrari has slightly lower coefficient of drag and will use slightly less fuel. However, for simplicity's sake, let's say they use the same amount of fuel and that fuel makes the same amount of noise. Then again, we can see that in the Ferrari, the same noise goes through 7 times as much silencing, and so the Ferrari will sound much quieter than the Smart car at the same constant speed. So the conclusion is this. In a stream of cars at constant speed, you should expect the smaller engines to sound louder than the larger ones. Of course, the Ferrari will make more noise when driven hard, but it won't make any more noise than the Smart car because both have met a legal limit that limits the noise level when driven hard. In practice, at constant speeds, the tire noise should be louder than the exhaust. Only at constant speeds in excess of 80 miles per hour might you expect the exhaust to be audible over the tire noise. In short, if you can hear the exhaust over the sound of your own car, it's going to be illegal.